Section 2.2. We're going to be talking about some basic differentiation rules. You can think of these as shortcuts to the limit definition. And that's really what they are. All these rules were derived from the limit definition. So first rule we're going to talk about is taking the derivative of some constant c. This is any number, it's just a constant. And that is always equal to 0. So let's say we need to take ddx of 8. That's 0. Okay, the next one I want to talk about, one of the most commonly used ones, very important one, it's called power rule. Well, a power rule does, well, before we do that, in order to use power rule, and this is very important, all exponents must be in rational form. All of them. Okay? And this is a very important point. And do a quick review on rational exponents. So if I have something which looks like this, you rewrite that as a rational exponent as x to the 2/3, where the top one is power, the bottom one is your root. Okay? Or if I have square root of x, that is x to the 1/2. You must convert anything like this into this, or you get to use the limit definition. Another thing we need to talk about then is if I had 1 over x squared, that can be written as x to the -2, where this indicates the reciprocal. And this should look familiar to you guys. Okay. So let's come in and take a look at the power rule. Ultimately, what the power rule says is first multiply coefficient by the exponent. And you should remember that coefficient is the number in front of it. If there's no number in front of it, it's 1. Then subtract 1 from the exponent. Okay, let's do an example here. The derivative of 3x squared. Okay, so first I multiply the coefficient, which is 3, by the exponent, which is 2. I'm going to have 3 times 2. Then I put my x, and then it says subtract 1 from the exponent. That will be to the 2 minus 1. Now I simplify, that gives me 6x. Okay? Now let's come back in and let's do the limit definition of this workout. And it should give us the same thing. So if you remember, the limit of delta x goes to 0. F of x plus delta x minus f of x over delta x. Okay. So there's my f of x, it's my 3x squared. So I'm going to have a limit. Delta x goes to 0 of 3 times x plus delta x squared minus 3x squared all over delta x. Okay, I have to expand this out. Have 3 times x squared plus 2x delta x plus delta x squared minus 3x squared. Right? And I'm going to distribute. I'm going to have 3x squared plus 6x delta x plus 3 delta x squared minus 3x squared. But this is all over delta x. And sure enough, those go away. So now I'm going to factor out a delta x. Gives me 6x plus 3 delta x over delta x. Those divide out to 1. So I'm going to have the limit, this delta x goes to 0, of 6x plus 3 delta x. That goes to 0, which gives me 6x. And sure enough, it's the exact same thing. Now, I don't know about you, but I think I would prefer to do this, But the price of using the power rule is you're going to have to work with rational exponents. Okay, let's deal with another example. Say I want to take the derivative of the square root of x. Okay, the first thing I have to do is rewrite this rational exponent. It's e dx of x to the 1/2, because the power here is understood to be 1, and it's a square root, it's d dx of 1 to the 1/2. Then I go in and I practice what I'm doing. Okay, my coefficient is 1, it's not written, it's 1/2 times 1 gives me 1/2 x times 1/2 minus 1, which is going to give me 1/2 x to the negative 1/2, which works out to be 1 over 2 square roots of x. Because of this negative, this x goes in the denominator. Okay, let's work on another one here then. 1 over the cube root of x. Again, I've got to rewrite this. It's going to be x to the negative 1/3, because that's in the denominator. And then I take the derivative, use power rule. It's negative 1/3, x to the negative 1/3 minus 1. It's going to give me negative 1/3, x to the negative 4/3. Which is going to give me negative 1 over 3x to the 4/3. Okay. And we can rewrite this as negative 1 over 3 times the cube root of x to the 4th. And as you can see here, I could actually simplify this to 1 1/3, so it becomes negative 1 over 3x, okay, that takes 3 out, times a cube root of x, which is what we have left. Okay, another nice property that these derivatives have, like limits, they're linear operators. So the derivative of some horrible looking polynomial want to say, is just the derivative of each one of the terms. Plus the derivative of the second term. And then I've got a minus dx. All right. Okay, and then we take the derivative of each term. So 3 times 2 will give me 6. X, we'll subtract 1, plus 5 times 1 gives me 5. It's x to the 1. 1 minus 1 gives me x to the 0, which is 1. So that just gives me that. And that derivative is 0. So that right there is the derivative of what I'm dealing with. Okay, now let's take a look then at what happens when you get something which looks a little nastier. All right, we'll learn another way to do this here in a little bit. But one thing you can do is to rewrite the denominator. So that means I'm taking the derivative of x to the negative 1 times. You should recognize this type of problem. I get you do one of them in pre-calc. 3x squared plus 2x plus 1. And now I distribute this in. Now I've got the derivative 3x squared times x to the negative 1. Subtract the exponents, that gives me an x, plus x to the negative 1 times that, go away, 2 plus x to the negative 1. Okay? Alright, so now we take the derivative of each individual term. The derivative of 3x would be 1 times 3, that gives me 3. 1 minus 1 is 0. Plus, that guy goes to 0. Okay, so I'm not going to have that term. It's gone. And then I do this. Negative 1 times 1 will give me negative x. And then minus 1 is to the negative 2, which means I've got 3 minus 1 over x squared. And that's the derivative of this stuff. And this is what I'm going to be expecting you to be able to do on this first homework.